That was great. Thanks for that set of graduate students. So I'm going to talk about a topic I think that relates to some of the graduate student topics as well and kind of sets a little bit different frame around agroforestry. It's really looking at this idea of a landscape perspective for agroforestry so that we can actually think about the next step in really planning out agroforestry practices. So in agroforestry, there's been a really strong emphasis on these 5 practices: alley cropping, forest farming, riparian buffers, silvopasture, and windbreaks. And we've most recently added urban food forests as well. But it really has us focused on a very site scale perspective. We're kind of thinking about just this one habitat and maybe not thinking about thinking really well, I guess, about how it relates to other habitats within the broader landscape. So I'm going to start talking about this perspective, this kind of landscape scale perspective that could offer us a better alternative, especially when we're thinking about wanting to design these landscapes for more than one function. So really thinking about this multifunctionality aspect, really thinking about the ecosystem services framework and how we can really stack a range of different ecosystem services together. And then the idea of resilience. So climate resilience, weather resilience, these are big issues that I think are better taken on at this broader scale. So we can start with the general idea of landscape ecology. And some of you are probably pretty familiar with landscape ecology. But basically, we're looking at something that they call the patch corridor matrix model. So we're talking about patches being kind of oftentimes the good woodland patches, forested patches. A corridor being the area that often connects those, and we'll see that like in a riparian corridor is very common, but a windbreak can also act as a corridor. And then the matrix is kind of the background land use. So that's the one that's the most common. In our settings, it's usually agricultural land use, but it could also be an urban land use. So if you're an urban planner, you're looking at kind of an urban built matrix and talking about the other pieces of the green space usually, which are the patches and the corridors. So this patch corridor matrix model has been around for a long time. A lot of work on that. And if we look at that, we can think about how these different aspects of the landscape function. So we start to think about more than just, again, these individual habitats, and we start to think about how they connect to each other. So even with a corridor, there are different types of functions that a corridor can provide. It's not only providing flow. The corridor itself, even though it's linear, is its own habitat. And it's actually a unique habitat, even unique from a patch, because it has so much edge. And so a forest with edge is a different setting. There are different species in there than like an interior patch. So it has its own habitat value and certain species that work well in there. It can serve as a conduit, and that's often what we think about the movement of materials. It can act as a filter, so it can keep materials from moving across. It can also act as a sink, so it can store materials or energy. It can be a source when it has stored materials, like maybe nutrients or something. It could be a source. And it can also be a barrier to keep things from going through. So it can serve any one of those functions. So the patch corridor matrix models is widely accepted kind of in the area of landscape ecology. The one problem with it is it kind of creates this dichotomy between the good landscape and the bad landscape. So it's kind of saying like the forested area is the good stuff and the matrix area is negative. So this real dichotomy, which is kind of placing that distinction between like the conservation and the production aspects and opposing those to each other. So the next step in looking at that is really thinking about the matrix itself and thinking about matrix quality. So if you look on the upper portion here, we have that dichotomy, the less suitable matrix. Then we start to think about, well, what happens in that matrix if we actually improve the quality or the suitability for wildlife or something like that within that matrix? And agroforestry is so great to think about that. So if you look at the item I have here on your left, and think about how we integrate agroforestry practices into that matrix, it's improving then the matrix quality. So that's the general concept behind that we can build on. And then a final aspect that relates to a lot of my research is this concept of multifunctionality that I'll talk about a little bit more later, but it's thinking about how we stack different functions. So typically we would think about the forested habitats more in terms of their ecological functions, and we would think about the agricultural land in terms of its production functions. But we're suggesting with this broader landscape scale that we actually think about stacking all of these functions, and even think about things like a riparian buffer that could also be productive. It could have productive species, woody species, specialty crop species in it. So that's a great framework for some of the things that we're going to do. Using this broader landscape scale perspective is very useful, I think, if we're talking about creating a culture-based food supply, and one that can actually support human health. And I've been trying to emphasize that when we talk about human health, let's think about humans as part of the ecosystem. We're organisms within that ecosystem, and if we're not healthy in terms of our diet or our physical attributes, then we're an indicator that there's something wrong with our environment. So thinking about human health, values, if we start to look at these two pieces, the people and the land, we can think about the past. In the past, we can look in the people end to traditional knowledge, thinking about medicinal benefits, harvesting methods, different sharing strategies within a community. Or in land, we can look at a native forest as being the kind of historic portion of the land and the diversity and the types of resources. If we look at our present situation, on the people end, we can look at community health, thinking about human nutrition, physical activity, cultural connections. And on the land end, thinking about sustainable land use and things like forest preservation and carbon sequestration. And then projecting into the future, people end looking at community resiliency, thinking about resisting health decline over the long term and retaining some of this historical knowledge so that we can continue to draw from that in the future. And on the same end with environmental resiliency, so looking at adaptation to climate and other issues that we talk about as we're moving into the future. So good examples of this are from Native American tribes for sure. So this is an example of the Crook tribe in Northern California, and just thinking about how they manage some of these agroforestry types of systems. Agroforestry is not new. We didn't create this. Things like these activities have been going on for many, many, many years. And so looking at like medicinal herbs and other products, and just starting to understand that traditional ecological knowledge and not just drawing from it and using it, but connecting it with the people who originated it. So I think that's an important aspect of it. The next phase is like, so we're looking now at the landscape scale. Now, how do we use this to actually do a landscape assessment? What do we do with this information? So at the landscape scale, we can start to very strategically start placing some of the agroforestry practices and do this in a way that we might optimize the benefits. So we can use landscape assessments or landscape analysis to think about problems and where those occur, think about opportunities, looking at the sources and causes of problems, thinking about flows across the landscape. What's the structure of the landscape and how does that control sources and movement? This also is not a new concept at all. So a really good example is the Prairie States Forestry Project, which occurred as a result of the Dust Bowl in the 1930s. And so across the Great Plains, of course, there was this tremendous dust storm related to annual cropping systems and not having treed systems. So because of this particular project, which used landscape analysis, they were able to actually install 18,000 miles of trees on that area on 30,000 different farms. Isn't that incredible? Just think about that many landowners that were willing to place something on their properties. And so they used something that's not unlike what we're doing today. They used spatial analysis. They were looking at how to prioritize where those resources were going to go. They only had a certain number of dollars to be able to put into this, so where do they place those so that they have the biggest impact? And so they started looking at things like, where to locate in terms of the biophysical features, but also economic data. So a very effective strategy. And then today we do something very similar, now using GIS. We have better tools for this and can use GIS to start to think about ranking and combining different data layers so that we can start to develop more of a suitability analysis for different types of functions. So in this case, you might take start with your question, identify the different variables, mapping out those variables, developing the ranking criteria, and then mapping the rankings and overlaying those. And then you come up with something visual that's helpful for people to see. So with landscape analysis, we have a quantitative component to that. There are a lot of pieces of that we can quantify. And, but we're also able to actually visualize it as well. And so this is an example of taking these different pieces and looking from a landscape multifunctionality perspective and combining the trapping of water quality, wildlife, even looking at florals for different markets, and then ending up with that final map of trying to take all of those pieces and identifying maybe where the first target should be for change. And I'm going to take you through a case study really quickly, which is 5 years of data in less than 5 minutes. 3 minutes. And so this is a project that was funded by USDA, and these are the different steps of it. They all kind of build on each other. We started with surveying the stakeholders, so it's very similar to what Ray Lynn is doing right now. And in this case, we were looking at Illinois, at a certain watershed in Illinois where there had already been a lot of data collection done, so it made sense to connect with this upper Sangamon River watershed. You can see the scale of that watershed and that it runs across a number of different counties, including close to where the University of Illinois is located. So we were really looking at farmer preferences for ecosystem services and conservation, thinking about their adoption potential. We're looking a little broader than agroforestry and actually considering all perennial types of habitats, and then looking at the key barriers to adoption. We did a cluster analysis based on those responses to cluster farmers into different groups. And so we clustered them based on whether they're high, medium, or low adopter likelihood. And I'll just share with you the high adopters here. We had a group that was educated networkers, and so they tended to have a higher education level. Farming was a secondary occupation. And then young innovators were young and highly involved in decision making. Looking at the next step was mapping out what was going on. And so this was that suitability analysis that I'm talking about. Here, looking at soil erosion and marginal land, taking these different layers and finding that area where they combine to find the highest suitability areas. Then we map it out. So you can now visualize the kind of red-yellow areas are the ones that are most suitable for these types of crops, which means they're probably least suitable for annual production. So they're in the upper reaches of this watershed mostly, or near the riparian zones is what we're finding for the most part. And we found that they were distributed a lot of times in areas where crop productivity was actually low. And so there was a good match between the suitable areas for converting and areas that were low in production. Another thing we did was take that whole watershed and model out a scenario as if we converted those most suitable areas into a perennial type of system. And by just converting 7% of the land, we were able to reduce the soil erosion in this model by 56%. Moving on, looking at design scenarios. So we worked intensively with 16 different landowners in that area to develop very personalized designs for their farms. And so we gathered information from the previous aspects from the survey and the map, but then we also worked iteratively with the individuals themselves, these landowners, to develop different designs that looked at ones that were more production oriented or more conservation oriented or more cultural oriented. And these were the types of outputs we provided. So a lot of visualization so that they can start to really think about what this looks like on their property. And we were matching it with the areas that they also felt were marginal. So we mapped out what we kind of thought were marginal or suitable lands, but they knew what the areas were that they would convert. So that's basically all of that study in a nutshell. And this was basically pulled from some work that I did with Gary Bentrup, who works for the National Agroforestry Center. And he and I kind of share we'd actually corresponded a lot. This was the first collaboration that we actually had that was a more formal collaboration, but we've talked a lot because he and I both have a background in landscape architecture, and so we both have this kind of landscape scale perspective. So by working on this chapter for the next edition of North American Agroforestry, we were able to kind of meld those views together and put it into a package that we feel like could be useful for the broader audience. All right, probably no time for questions, so we'll keep on moving.